the MWD Reading Symposium. Loving the crowd. Thank you for being here. My name is Ben Rivers. I'm with Federal Highway Administration. I'm going to be moderating this session, and Mary Nodine, my colleague right here, had done the heavy lifting for this event. And let me tell you, I think it's a fantastic program. So I'm going to run you through what to expect during the next 3 hours. In a little bit, we're going to start event 1, and Jean Benoit, who's sitting right here, and Mike Rogers in the back, both gurus in MWD. They're going to be leading us through an MWD 101 for the first 30 minutes. After that, we're going to break you up into 3 groups, and we're going to rotate you through the next 3 events in those 3 groups in 30-minute blocks. And so we've got in store for you a workshop that's going to be right here, so you're going to be able to look at the data, get familiar with what you're seeing from MWD, and ask questions about interpretations of those. So we're going to walk you through some examples. We have 3 vendors over next door in room B, so you will have an opportunity to interact and learn what wares they have available for MWD, get familiar with their systems, ask questions with them. They're also exhibiting here at the show, so you can follow up with those vendors as well. Then we have an outdoor instrumented drill rig, and we're going to give you some time out there with several folk who are familiar with instrumenting drill rigs, so you can ask the questions and lessons learned about instrumenting, getting up and running, as well as the vendors over here are going to be helpful as well with that. So for those next 3 events, we're going to be rotating you in 30-minute blocks in those groups A, B, and C. And then after that, at 4:15, we're going to come back here, and we're going to close out with looking toward the future of MWD.
Thank you, Ben. You can hear me, right? So I'm Jean Benoit. I've been called worse. Sometimes I get called Jean Benoit, but I respond to just about anything. So this is MWD 101, or MWD for Dummies, I guess. Okay, I insulted everybody already. It's a really good start. So this is the program here. I'll do a little introduction. We'll go over some of the equipment. We'll look at drilling parameters, and we'll talk briefly about the standard that will be that Ben is working on, and with some conclusions and perspectives. And if you have any question, you can certainly stop me anytime. So what is MWD, measurement while drilling? Okay, it's a computerized system, drilling monitoring system. So essentially you continuously and automatically record everything that goes on during drilling. So you're going with depth, and so you record everything every 5 to 20 millimeter. You can also record parameters with time. It doesn't really interfere with the drilling operation. All the sensors are on the rig, and the driller just does its usual work without having to worry too much about the system. It just basically start and stop every time you add a rod. Real-time display, so there's all kinds of, you'll see some of the display here. Some of the vendors have different monitors, so you can look at that and see how it looks in the field. Everything is stored electronically, and it's easily installed on any drill rig. Easily means it's not going to take you 2 weeks to do this. We can do this easily in a day with someone that's mechanically inclined. I think it's fairly easy. Typical application, certainly we can improve the drilling efficiency. We can really do a good job with geologic profiling, detect voids, fissures, other anomalies, and you can manage the drilling operation. It's not like Big Brother looking over the driller, although now we have some software that we can actually access the monitor from the office so we can see.
I guess what we're going to do is I'll just give a quick introduction. I'm Jack Foran. I work with the Bureau of Reclamation. Recently implemented MWD on one of our fully hydraulic drill rigs. So I'm out here to really answer your questions about how to install the things, what kind of data we get from them, which presenters did a really good job in the last hour kind of showing all that stuff. We're really here to answer questions about installation. We've installed the MWD system last year. We have a Gene Lute system. This is an LIM system. I'm sure there are a lot of similarities, but Francois will be able to point out the specifics of the system.
Can you start with like what are the different types of? You'll do that. Okay.
Okay. Well, then
No, go ahead.
I don't have much else to say. I'm here to really answer questions, but we'll just go over component by component what's on the rig, and then we're going to go over what it looks like on the screen and that type of thing. So with that, I mean, do you want to talk about the different sensors you guys have?
Thank you. Guys, so I'm Troy with GeoProbe. So what we did is we brought a rig here today that has MWD on it. So it's got the sensors in place. In most cases, most of these sensors are already on the rig. This is an example of a hydraulic rig. So you heard a couple types mentioned earlier. Most sensors are on the rig. We added a few for MWD. So anytime an MWD kit is added, a few sensors are installed. One of them being the depth encoder. It's a wire type and it's up on the mast, which we won't be able to see from inside the tent here. We also install a mud pump pressure or mud pump flow sensor. And so there's a few things like that we're adding to the rig to a standard rig to make it MWD ready. And then we're using a recorder like the LIM device right here behind me that's collecting the data. So the idea of what we're trying to do is make sure that we have a setup rig that can output on the CAN bus and get recorded to a digital logger. And so what I'm going to do now is have Francois talk about a little bit more about the LIM and how we're recording and what parameters are being recorded. The poster right behind us right here is going to show each of the positions approximately of what's being recorded. So this is a repeat of what you saw earlier. There's a position which is also taking care of depth and rate of push, which is going to be the depth encoder, rotation speed and torque, head pressure, mud pressure, mud flow. What we'll do in the system here is we'll calculate the mud flow, torque, and head feed from hydraulic measurements. So you can see the blue or the orange circles identifying where the locations are. What I'm going to do is have Francois just show you where they are on the recorder, and we'll kind of lead in from there.
All right, I'm Francois with LIM. So we manufacture like those guys, measurement while drilling. If you want to get closer, I will just show you like on the screen. If you want to see what parameters we are recording, what we can see. So this is the main interface. When you have digital values, you would see on the top left the thrust pressure. If you push on the button, you would see actually the force, actual transmitted to force. Same thing for the torque. We have the torque pressure over here. If you click on it, you will see the true torque, the force, right? We have the all back pressure, we have the RPM, we have the injection pressure, would be like your flow, your mud. You have the, your mud or your water, sorry. Then you have the flow, that would be the flow of the water of the mud. We have the gear ratio as we put it in, like the drill rigs have different gear, of course. And then here you have the penetration rates in feet per minute. And here we have like two different depths. I will show you that when we're gonna run the drill rig. We have the drilling depth, down the hole depth, and we have the tool depth, where we track your tool. All right, so before like we start the drilling, very simple, you press start. And on start, there's several information that you enter once, such as the drilling method you're using, what type of project, the number of boreholes, who's the driller, etc. Those kind of information that you enter it just once, and then after they are appearing on the header of your geotechnical report, right? So when you're ready to drill, you can actually press, are we ready? Cool. So I press play here, and you will see like the different parameters like moving. So this is actually the view, the digital view of the value. And you can actually switch it to graphs. So what's the best view actually is watching into graphs, because you actually see the variation into your parameters. And for example, when you'll get into different layers into the ground, you will see variation. For example, slowing down of a penetration rate with an increase in of torque, you might get into other layers, right? So that's what we can see. Like, it's very hard to see right now on that screen, but we have like some advancements. You can actually change the color of the screen. You can put it into like a black and white. We actually should have done that so you have a better view. So once you reach up, we can pause. Oops. Up. That's good. Once you have done your first auger, your first rod, you can actually you going back up. So you know what I was explaining about the down the hole depth and the drilling depth. This is where we're ready to add the new rod. If I click on that button when the rod has been added, both depth are matching. That means we back down the hole. We can start recording again. We can start drilling again.
That's the adding of the new rod.
That's the adding of the new rod.
That has a specific length to that rod.
Exactly.
That does the math for the
Exactly.
exact depth
That
you're at.
that is correct. That is correct. All right. What else we can do? That's I would say like the specific view on that. Now we can probably stop the drilling. When you're done drilling, very simple. You press pause and you press end. And what's happening is like there's a SIM card inside. You can also connect it to the Wi-Fi. It transmits the data directly to the cloud, directly to your email address, and you get your reports in real time, basically when the drilling is done, right? So I also have to insist that the system, like with the software, you can actually create your own templates, and all the reports will arrive as you create your template. So for example, if there's a parameter you don't want to see, you just delete it, and all your reports will come without these parameters, okay? Few other things that is available with that system that my colleague will talk about is like we can also get information proper to the drill rigs, meaning like productivity, efficiency of the rig. So that's something we tap into the CAN bus of the engine, and we get information from the rig. So this has nothing to do with drilling parameters about geotechnical information. This is just for drill fleet management.
Really important that people ask questions. A bunch of people here. Is anyone familiar or have one of these systems on a rig? Or plan on putting one on a rig very soon? You do? Okay. Is it a mechanical rig or a hydraulic rig?
We got both.
Both of them? Okay. So we've installed one on a hydraulic rig like I was talking about earlier. These sensors are all hydraulic. They're pressure transducers. That's how he's getting these data. And I want to show you guys this thing right here. This is a direct measurement system. So this goes on an AWJ rod. They make all sorts of different sizes. This company's NWD1. It's Mike Rogers who was presenting earlier. It's his company. So they provide this, goes directly into the drill string and directly measures force on the drill string and torque. So it's a lot more sensitive for light loads on the drill string than the hydraulic measurement would be.
For light loads.
For lighter loads, yeah, typically you'll get like, for smaller loads, a lot of the signal gets lost in the noise of the hydraulic pressure transducer. So, yeah.
Is there a difference in the data you get when you install in a hydraulic rig versus a conventional rig?
Well, yeah, I mean, like your mechanical rigs you aren't gonna be able to tee into hydraulic lines for those rigs, right? So you're gonna need a direct measure system to get force and crowd, or to get crowd and torque. Yeah.
So for Sonic, usually you get the best measurement of the measurement while drilling. It's the penetration rate. The problem of like Sonic drill rigs is like you have a constant push, right? So it's not very interesting to look at the penetration rate. But we can retrofit some rigs with for example, frequency like sensors that give you some information about different layers, of what you get into the ground. So yes, there's this possibility, but there's more research to do on the sonic drill rigs.
So this thing is really easy to install. Mike works with both LIM and Gene Lutz. They provide instructions. It comes with an instruction packet and a wiring diagram. And I'm not an electrical person, and I can do it. So.
But so for example, I can.
Yeah.
So how is it run on probably Jean Lutz's system, and I can talk for hours on what we set up on with this sensor is like we connected the sensor to a USB, and it's like wireless communication. So the sensor is on the rig, right? And it sends data directly to a USB like receiver, and we get the information wirelessly.
It records it.
It records and display.
It's not controlling it.
No. You can think about this as like this is automatically taking notes from the driller's input to the
But
rig.
the driller is still controlling.
Yeah.
Yes.
The driller can look at this and actually adjust his operation.
Exactly. He can manage the way to drill. Exactly. That's what Mike was explaining earlier. The optimization of drilling, for example, doing coring, that's exactly what the drillers do, is looking at those information and say, okay, I need to find my sweet spot to get the best core recovery, for example.
So what's he looking at to do that?
Sorry?
What parameters is he looking at to do that?
Penetration rate, rotate. He's looking at penetration rate, the RPM, the flow rate. All of those things are going to be real-time data on this screen.
You want him to look at more than 3 things?
The drillers are smarter than you give them credit for. What? Hey, so I will say this is a thing. These are parameters you set for certain drilling methods. This is something you probably do with an engineer on site, and then the engineer would be like, "Hey, these are the things we're going to run with," and you go from there and do that. Yeah. People are doing machine learning models for a lot of this stuff. Yeah. Yeah.
There will be a presentation about machine learning in your next event.
Good questions, guys.
You have to have that.
Where are we going with this? So, I mean, just getting a flavor for the basics of this, running through some examples, seeing what's involved. I mean, at the end of the day, I think better site characterization, specifically materials that we have not been able to do a really good job characterizing in the past. We have CPT method for soil, where we're getting into rock, karst, bouldery materials. This is where this is really going to shine. And so better characterization, within these types of materials, certainly engineering correlations, you sort of got that flavor from what Mike was showing you in the example, and how if we control the efficiency of drilling, we can really dial in the resolution, even within soils, and that's going to be critical when we're looking at engineering parameters. So better data also for assessments. And what you're seeing here is just a very rudimentary type MWD system. This is a class 3 system. It's a rotary percussive system. It's only measuring, if you look right here, penetration rate and some kind of work index parameter that has to do with the energy going in with the hammer and essentially the air pressure that's being used here. And you can distinctly see these changes in here and see where voids are occurring in this karst material. So a rudimentary system can be quite powerful, especially if you have additional information. So this is sort of the direction I'm seeing we're headed. The question is how do we get there, and standardization, as John had pointed out, is certainly critical in that part. Our speakers are going to show you how we can start getting to that location. So with that, I'm going to bring Tushi up here, and she can start us off.
Good afternoon, everyone. My name is Tucha Bashar, and I'm an assistant professor at the Department of Civil and Environmental Engineering at University of Illinois Urbana-Champaign. We do have an ongoing project, MWD project at the state of Illinois, where we've been working with Illinois Department of Transportation on improved characterization, subsurface characterization especially for the Illinois subsurface. So today I will just give the advances that we have been working on, especially for this MWD project. And when you think about, when you mention future, I think in these days, the first thing that comes to mind is the artificial intelligence. Can we use artificial intelligence in MWD predictions, or use artificial intelligence in MWDs to get whatever we want from our exploratory drillings or design parameters. So introduction about machine learning. So this is the science and engineering of making intelligent machines, as John McCarthy was identified artificial intelligence. Today, machines can learn at least somewhat like human beings do. So one thing that is one of my pet peeves, people use AI and machine learning interchangeably. This is not true. So AI, I see a glove, yes. So AI refers to the development in computer systems to perform tasks that require human intelligence to complete. So there are variety of techniques of AI, including machine learning. So this is, for example, it's been used for earthquake magnitude estimation in one of the applications in geotechnical engineering. And we have speech, and this has been used for sound detection, construction safety. We have vision, you see image recognition and machine vision. It's been used for soil classification. Robotics in the Perseverance for the rock collection from Mars. Planning and optimization, which is autonomous pressure balance control for TBMs. And there is expert systems. I do not know any study yet about experts. If you do know, please let me know. If you're interested, and there's also natural language processing, where we use it in ChatGPT, for example.
So I'm going to talk about revolutionizing foundation construction using MWD. This is the site we did here in Florida. I'm all kind of safe distance, just monitoring things. We had the system all hooked up in here. This is kind of the old school way we used to do it. We would tap into the electrical unit, but as you probably found out from the MWD vendors, we can actually just tap into the onboard computers on these drill rigs and take that data, quickly collect it and assess it. So with foundation construction, especially in Florida with our weak limestone, highly variable conditions, we really have two sources of uncertainty here. We have spatial variability, which is going to generate uncertainty. So we have spatial variability in the horizontal direction as well as in the vertical direction. And then another source of uncertainty is method error. So if we were to run a boring here, make a prediction of the capacity, and then we went in and installed a shaft and load tested it, we would have the predicted resistance and the measured resistance. This black line would be a perfect prediction if it fell in there. But we're going to see our data points somewhat scattered around us. So I'm going to show you how we can tighten up that scatter using MWD during the installation of drill shafts as well as undercast piles in Florida limestone. We're focused on side shear here.
Gustavo's been working with some of the local contractors who build CPTs and MWD. They're trying out the equipment on the rigs and everything. They're like, how do we process this data? How do we deal with our customers and give them a tool that's usable? So we've been developing this internal workflow project management system we call Mortar, which is on top of that thing that really kind of handles the borings from the time you plan them through utility clearance and everything. It just tracks data, tracks the whole workflow process. And in the background of that, it's doing some analysis and stuff for us as well. And we took that and said, well, what else could we do with it to help these folks out with CPT and MWD data? And what we came up with was this process where, do we not have? Process where we created an API. You don't have internet service anyway. Get away from me. I won't get to show you the live version then. So, what we're using is basically an API that allows them to take the raw data files from the field, whether it's CPT or MWD, upload them to a web server. That web server uses Mortar in the back end to do all the analysis. The stuff that you used to take the data, drop it in an Excel spreadsheet, manipulate it, and calculate all the compound parameters, the QTs and everything else. And spit it right back out to you within seconds, less than seconds. And you're able to then look at it on the screen and decide what you want to do with that data. This isn't a touch screen either. Look at that, it's in the way. So you've got all that equipment, we saw all this from the drill rigs and everything, but now we're able to upload that data, and this API really kicks back the data right back to you. It allows you to turn on parameters, turn off parameters, look at them compared to one another. You know, this is a beginning example of this, but it's kind of nice when you can say, all right, we're gonna, compare depth of penetration with torque, or we're gonna compare it with some other parameters and start in real time looking at this data and understanding what it means.